Welcome, everyone. Thank you for coming. I didn't write this tool. This tool is really complicated. I couldn't even imagine it. So the first things first, how to pronounce it. Is it Aleph? Is it Aleph? I don't know, but I would call it Aleph. So there's a QR code. If you trust me, I think we're all friends here. So, I mean, just go ahead, scan that QR code. It takes you to this exact page. So you're not going to, yeah, don't look at the link before you click it. So before I get started, I kind of want to, what is the purpose of this talk? So a lot of people that know me know that I'm just the person who's always digging through the garbage of data breaches. I feel like it's a topic that doesn't get a lot of press, doesn't get talked about a lot, but it is useful for whether it's privacy stuff, whether it's OSINT, whether it's pen testing, or even blue teaming. Data breaches, in my opinion, are important. So the point of this talk, what am I trying to sell you on? I'm trying to sell you on using this tool to analyze data, whether it's data breach data, which I'm going to cover ransomware data sets in this talk, but it could also be file shares or just your own personal stuff, or it does OCR, it does a bunch of stuff that could be useful for other side purposes. Yeah, you all know me. Just come talk to me if you don't know me. I'm going to pretend like we're all coworkers and friends. So data breaches, why are they hard? So it's a constant battle between collecting data breaches and finding them and analyzing them. So you might have terabytes of data, but if you can't analyze it, then it's pointless data. It doesn't do anything. Ransomware data sets pose unique challenges. So this 51,000 number, if you go through the CLOP ransomware breach that's been released, it's about 24 terabytes. And in that data set, there are 51,000 file extensions. So if you could imagine trying to even begin to parse 51,000 different types of files, whether they're structured text, images, I don't know, like random software packages, financial document formats that are used by weird specific tools, it's pretty much impossible. So the goal is like make the data, just like have something to throw the data into and make it searchable quickly and easily. That's where Aleph comes in. It basically is designed for journalistic purposes. So if you look at the top, there's this aleph.occrp. This, let's click the link just to show you sort of what the basis of this tool is. So like, you know, Putin. This is a public data source that is indexing. The OCCRP is a journalistic entity that's indexing. You can see some of the data in here. So it's France companies index, Russian companies. These are like journalistic type of data sets for doing something like reading Donald Trump's emails or whatever it is. So that's what it's built for. I actually found out about this from Micah Lee. If you're not familiar with him, definitely check out hacksandleaks.com. He has a no search book coming out that's going to be really cool. This is where I got this idea. So, you know, credit where credit's due. So I did want to do some sort of comparisons of what other tools you could use. So like I have here, the duality of grep. It's always the best tool for the job, and it's also the worst tool for the job. So like it's immediately accessible. You can grep anything immediately right there. However, if I grep a PDF or a JPEG, I'm not going to get any useful data. If I have a bunch of data that's in a JPEG format, I can't grep that. It's binary data. Or even like emails are in MIME format, you can't grep that. So there's a lot you can't grep. But Snappler is another option, right? If you're looking for candy, delicious candy, you can just run a Snappler on a local directory even, and just find me all the passwords, and Snappler will do it. And then, you know, there's some others. I've actually talked about using LLMs or other things to like analyze data sets. I don't know. That's way above my head. So I want to talk a little bit about hardware. During this demo, I'll run this off my laptop. You can run this tool on your local device. It doesn't have to be scaled to this huge, you know, big computer. It can just be your laptop. I did want to say, like, and I'll obviously please use this if you're going to run this tool. Like, read this. I'll probably just skip the installation so I don't run out of time. But it is kind of space intensive. It will inflate your data set to roughly 2 times the size. So like if you have a 60 terabyte data set, you'd need 120 terabytes of raw storage. or whatever the numbers are. It will vary based on what your data is. So if it's text data, it's going to expand a decent amount because it's going to be trying to index a lot of text that it needs basically to put that in the database so it can process it. If it's images, it will be extracting very small amounts of data from the images. My personal setup, just if anyone's curious, I use Hetzner. It's a German hosting provider that you can get really cheap dedicated servers like this box, the AX102. It has a Ryzen processor, 128 gigs of memory, and a 4 terabyte NVMe, and it's like $100 a month. So it's not that expensive. That will be like enough. Installation, I'm probably just going to skip this because I feel like we don't have time to install it. But installation is incredibly simple. You clone 2 files, you pull them out of a GitHub, you edit them. Handy, I already have them pulled down right here. So that's kind of crazy. I'm prepared. So basically, there's these 2 files, aleph.m. This is like configuration data for the tool. So you can set the title, you can set the URL. The secret key is just a random key. One thing I did want to call out, so for storage, we talked about how this is storage intensive. They've already thought of this. You can configure an S3 bucket for raw storage. So just natively in the tool, you give it a bucket, it just dumps all of its raw data there. It can save you hard drive space. So to get it running, all we have to do is we have to edit this key, and the other thing we do is we set it to single user mode, which basically disables authentication entirely and just lets us get to the tool immediately. And then the Docker Compose, of course, it's Docker. It's always Docker. If it's not, I don't use it. Basically, this is all completely off of the GitHub. The only change I made was I pulled one of the, it mounts the home directory into the container, which I just don't love that. So I commented that out, but that's it. Let's pull up the containers. I already have these downloaded, so it should work. That's famous last words, it should work. So I'm going to wait for it to be happy. Let me get some cool hacker stuff going. This is a cool little fun tidbit. This tool glances. It's pretty cool. It will show you, looks like it's not, maybe I have to run it as root. Okay, well, on Linux, it shows you containerized CPU consumption. So it will show like, for this container, it's using this much CPU, this much memory, which is really nice. It's Docker like aware. This is a Mac, so I don't know. Tim Apple broke it. So it looks like the containers are up. Let me check to make sure the web interface is working. Looks like it is. So this is like the basic web interface. Investigations, this is where you would come to sort of see your data. I already preloaded this Ferrari data because it takes like 24 hours to process, but we'll just pretend like I didn't do that. So we can do investigation. We'll call it test. So now we have this investigation test. Investigation is like a container of your data. So like a category for whatever you're working on. It could be investigation, or it could be like a company or a database or whatever. So to add documents the easiest possible way, you can just drag and drop. So here's my little data that I found. There's obviously all these files are intentionally put here by me, but I put some documents, I put some CSVs, I put some text files, some PDFs. So I'm just gonna, be lazy, just drag and drop. Sometimes it does this where it says, upload failed. I'm just gonna restart. Obviously that always works. So it's processing these in the background. Sometimes if it takes a long time, you'll see it. You can look at the system status page. It does all this tasking and stuff in the background. It uses a queuing system for OCR. It's really complicated and cool, but basically it keeps track of all the tasks it's trying to do. Import times can be long. So like this data is only like 5 files and like several kilobytes. If you're dealing with like large scale data sets, like terabyte scale, it's going to take like days and days and days. But so now we have these documents and let's browse. So, okay, in the web interface, I can just browse a Word doc. Even just this capability is nice. I don't have to like pull down a bunch of files. I don't have to mess with metadata or worry about potential macros or other things. Like this is just, I'm able to view this in the web interface. It also will give checksums of this data, and you can see some of the metadata. So this is notable, right? This is the author of the document. This is based on metadata. So like if, you know, you say you did say you pulled down a bunch of company documents from someone's website, you can see all the metadata in here. And then also, in addition to being able to browse it in the web interface, you can also just, it does text extraction from this. So this isn't, I don't think this is OCR. I think this is actually like data aware text extraction, but you can see here, this is the contents of it as it saw it. I don't know what this weird formatting is, but. So Aleph also does named entity recognition, which is basically a machine learning fancy term that means I'm going to go through your data and I'm going to try to find items that look like a name or look like a bank account number or look like a piece of text that I recognize. So it does this automatically when you import the data, and you can see here, this is the entities that it's extracted. It's very basic. It didn't actually find everything in this data set, and we'll go into why it didn't. But you can see here, you know, Bob Bobbington, I can click on his name, and this is all the documents that would be, that it found with his name in it. So if you're looking for a specific individual, let's say you're looking for your personal data in a ransomware data set. You load it all in here, you search for your name. This is going to give you a good hit right away. Also, of course, it has text searches. So we can just type password. Okay, no results, but we're tagging to Bob, so let's take that off. Okay, secret.txt, the password is secret. This is nice because this is like deep analysis of a text file. So like if the text file is like 100 gigs, it'll still try to index and read all the text all the way down to the very bottom. A lot of tools like Snappler, for example, it's only going to pull the first 200 kilobytes or whatever of the file. So this is this data set. You can actually browse the original documents. Like, so for example, ICAR, this is like literally just an A/B test payload. It won't let you see anything about it, but you can get a checksum for it. And obviously this is a safe way to at least view some metadata, I guess. I'm not going to say there's no code execution because who could ever say that, but you can like download the original file and it will warn you. It'll say, you know, you're about to download a file, and I can just download this. And now I have this ICAR file. So PDFs, it's the same thing. You can view PDFs in here. This is just a fake, very badly done driver's license that I just Googled, but you can see how you can view the file, and then also it would have extracted the text. So this is an email we didn't have before. This is from a PDF file. And also you can search, like, let's say we somehow knew this guy's address number. We could just search for this and it comes up. So you'll see when you're searching, the named entities will be highlighted. So like if it highlighted this as a named entity, it would be there. In this case, it was not extracted as a named entity. So it will be like, it'll show you the file, and you'd have to manually view the file to see, oh, this is why it matched, because this string is in the file. So I've imported some basic data. That's like, let me catch us up on the slides or whatever these are. So I've imported some data. You can also import data through the command line. So let's do that real quick. So importing data, you use a shell container. So in the Docker Compose, you will see this container. So this container is essentially preloaded all the libraries of the tool, and you just get into a shell, so you don't have to like install anything or whatever. So let's load ourselves into this container. So this is the command. Basically, we're running the shell container. That's at the very end. Of course, they put the most useful part at the very end. We're specifying to remove the container after we're done. And then this is a volume mount of just mounting this directory into the container with its read-only, so you don't want to mess with your source data. And then we're also for other reasons I'll explain later, we're mounting into this other directory that is writable. So let's run that. Here we are. This is the command line for Aleph, or Aleph. I always say it wrong. So this is where you can query things, but I put the directory at /ingest. Let's go over there. We can see this is the directory. You can see all the contents of the files. Yeah, Ferrari is a big one, so this will, yeah. But to index this on the command line, you just use Aleph crawldir test, and it will, like, it'll be verbose when it processes the files, but it'll load them in. You can see it's already done. It'll give you a little output index test, 0 things, because we already indexed it all. It does. You can re-index the same data again and again. It'll know that. It does checksums and all that stuff, which is really nice. Another like side thing, Aleph does recursive extraction of compressed data. So you might get a ransomware data set that is like 1 zip file, and then you extract that, and it's like 5 more zip files, and then you extract that, and it's like 10 more zip files. It just keeps going. So you can write a program that does extraction recursively, but Aleph does it for you. So you just load in. It kind of struggles with bigger zips, but if you just load in like 10,000 zips, it'll extract them all and make their contents browsable in the web interface. So like as you index data, the tasks will continue to climb as it finds more zips and extracts them and then creates more tasks. It does occasionally get stuck. So if I'll just look in the GUI because it's a demo, but essentially you can scale these up. You can see these are the Docker containers that it's using. The ones that, if it gets stuck, it's probably stuck because it's not running an ingester or a worker. Those are like the 2 components that do the OCR, the extraction of the data, all that stuff. Wow, this is like so much material to cover in like 30 minutes. We covered search. Oh yeah, I wanted to cover entity mapping. So as I mentioned, you can search for data immediately. You can type in password. Anytime that is referenced, it will pop up. That searches OCR, it searches entities, and it searches raw content. So the table I'm talking about, if we look at the documents, okay, that one didn't upload for some reason. Or maybe it's, okay, there it is. Like embedded files? Yeah. I don't know. It's a good question. The question was, does it extract embedded files within Office documents? I don't know, but that's a good thing to think about. And I will say, like, anecdotally, talking to other people that have used this tool, there's certain file types. It has modules for parsing a lot of files. There's a list that's probably in the hundreds of files, like docx, PDF, MIME types for emails, all that good stuff. But there are certain files, like I talked to certain financial organizations that were affected by the MOVEit breaches, and they use a lot of proprietary file formats that that it doesn't support. But you could do a pull request and add that support to it. There's other ways you can sort of hack Aleph into doing other things. You can also have it do translation as a post-processing task of a text file. So you can basically have it do parse OCR all this text, and then also run this through a Russian language translate service or whatever it is to get OCR data for whatever language that you're trying to extract. The only one that's supported natively is the Google Translate API, which is expensive. So if you have a key or you use that, you would be able to just plug it in and have it go. Otherwise, you'd have to build your own post processor. So this is example of mock PII. This is like a fake CSV that I generated, but you can see you can search through these CSV files in the web interface. You can, copy, paste, all that good stuff. I think I'm going to skip entity. Actually, no, it'll take like 2 seconds. It's fine. So basically, there's objects. All of Aleph is based on this schema called follow the money, which is a schema of object relationships. Like you can see them here: assets, bank accounts, companies, contracts. In this case, we're just going to do person. And the point of this is to enrich our data so that it extracts more entities, because it didn't find these names in the CSV. So we're going to make it find them by telling it where they are. So keys, this is basically you're defining these selectors will create a unique row on this on this data set. So I'm going to do first name, last name, and email. There's no way someone has the same first name, same last name, and same email. Then in the GUI, super easy. You just map the properties to the column. So I'm saying this is person. They're alphabetically sorted. So first name, last name, email. These are pretty self-explanatory. This gets really complicated when you get into like, it's kind of, think of it like Bloodhound on some level. So you can actually export the data as graph databases, and you can load it into Neo4j or other graph databases. Email. And then we're going to say verify. Cool. Sure, it looks good. And then I click generate entities. It'll show you, let's see, generating entities. It's thinking. Should be pretty quick. So now it says, let's refresh. So now it's done. Derived entities 1,000. That's how many rows there were in the CSV. And then there's all these people. Let's look at Felix. There's his email. He apparently works at NOAA. This is fake data. So that's mapping entities. And then, so as the last little 4 minutes here, I'll walk through a real data set. So this is the Ferrari breach. This is a ransomware data set of ransom EXX breached Ferrari. The reason I picked this is because the data is very innocuous. It's not sensitive. Well, there are some bank account numbers. Just don't look at those. But yeah, so here are the documents. This is like the file browser. So this is what they published. All of these are like, you know, marketing documents for Ferrari. So they're not that sensitive. But let's see. Let's look at our entity extraction. This is natively what Aleph has done. So all I did was load this ransomware data set into this tool. I did no entity mapping. I did no like manual parsing or anything. This is what I've got. So if you're looking at a data set, this gives you quick awareness. Like, I mean, a video. Okay, what is this? Like, you can literally just, okay, cool, a guy getting into a Ferrari, awesome. And like for ransomware data sets, this can get really brutal. This can be like call recordings or like internal documents and training. So yeah, let's search for, I don't know, Luigi. So it's like service documents, right? Here's all the mentions. Here's a phone number if you want to call. But yeah, like here's an example. This is a, I don't know, it looks like a service document, service advisory from 1963, apparently, or 1966. This is a JPEG for some reason. And like, we have this text that's been extracted. It's not going to be perfect because this document is from 1966 and it's like badly typed on a typewriter by some Italian person, but it's here. We can view it. So I guess like hopefully this shows you the power of this tool. Like, I don't know. I have no idea what this data is, but if you know what you're looking for, like I don't know, let's search for password. Only 204 results for password. This shouldn't take too long. But yeah, I'm pressed for time, but this gives you an idea of what it can do. This is like zero effort. Docker compose, load the files in, and now you have immediate awareness of some of the data that you didn't have before. So that's the talk.